Perhaps the professor could use your computer.
Please.
Computer? Computer. Hello, computer.
Computers are integral to our society, and they are getting more and more important each day. In 2002, 66% of Americans had personal computers. That number has been steadily rising every year. 43% of people said that computers played a very important role in their lives. As more people use computers, the importance of how easy a computer is to use will become more important. However, computers are not always the easiest to use. They can be complicated, unintuitive, or just plain hard to use. When asked what they thought about the increasing role that computers play in our lives, 31% of people said they were enthusiastic about computers. 58% said that computers' role had been both good and bad, and 8% said that they rejected computers altogether. 59% of people say that computers solve more problems than they create. However, 29% say that computers create more problems than they solve. When information technology project managers were asked what makes a successful project, the number one reason was user involvement. This growing concern for making computers more usable for humans is called human-computer interaction. In the early days of computing, computers were huge machines that only big organizations could afford. Because computers were so specialized, only a few experts ever used them, making them very exclusive. Users were professionally trained in how to operate computers and would often use very rudimentary interfaces to operate them. As time went on, more and more people who had no professional training with computers were having to use them for everyday tasks. Since these new users were not experts on how to use computers, they had more difficulty learning and understanding them. Computer designers did not put much emphasis on how easy and intuitive these computers were, since computers were originally designed to be used by expert users who were professionally trained in how to use them. With new novice clients buying and using computers, designers had to become more concerned with how humans interacted with their computers. As designers researched how general users use their computers, they started making changes to computer interfaces to help users operate their computers more quickly and easily. From then to now, human-computer interaction has played a significant role in how computers are designed and used. The Association of Computing Machinery Special Interest Group on Computer-Human Interaction defines human-computer interaction as a discipline concerned with the design, evaluation, and implementation of interactive computing systems for human use and with the study of major phenomena surrounding them. Human-computer interaction is a field of research that deals with understanding how to make computer interfaces easier and more intuitive for users. Rather than creating interfaces that are easy for programmers to make, the field of HCI emphasizes designing interfaces around the user. A computer can be fast and powerful, but if the user can't use it, then its usefulness is trivial.
All devices, machines, products, and systems eventually need to be used by users. So if you exclude that, then I think the purpose of the whole system is now under question.
The real interesting questions, I think, are how do you link that human with the tremendous amount of digital power that we have to make meaningful interaction.
In this type of a system, you really need to make sure that you are minimizing any chance or potential for human error through bad design or anything such like that.
Oftentimes, this lack of consideration for the user results in products that are poorly designed.
About a month ago, I purchased an external hard drive. And to tell you frankly, I mean, such a simple task as backing up a hard drive became almost impossible to me. And I'm a PhD in engineering. I mean, it should be easy. And then all of a sudden, a student of mine came to me and said, Dr. Amy, there is this software, why don't you look at it? I went to the demo. It was extremely simple to set up, extremely easy to use. I made an error in selecting the destination drive. The software came back with a warning window, dialog box. And this warning was so clear. At the top it said, it appears that you're attempting to do such and such. Very clearly said, do this, this, this. I call that a good, positive, user-centered design for this interface.
Bad user interfaces are not only frustrating, they can also be much more devastating.
This patient went for a radiation therapy and was in the other room, and the nurse entered the dosage. And then nurse realized that she or he made a mistake, tried to correct that, backed off, deleted that, and entered the new dosage. But because of the problem in the interface and the design of that interface, of that radiation therapy equipment, the machine did not delete the original dose and just the next dose that she entered was added to that. He got zapped by overdose of radiation, and that eventually killed him. The moral of this story is this lack of human factors consideration in general, or lack of human computer interaction in particular, causes harm. In fact, once one very important aviation accident, that was an American airline hit the mountain in Colombia. That was because of the bad design of the flight management system. The pilot wanted to enter a different beacon name, and he entered a different erroneous one, and it basically, instead of going like this, it went and hit the mountain.
This philosophy of changing computers to work better with users, rather than trying to change users to work better with computers, is referred to as user-centric design and is a crucial part of HCI.
User-centered design in HCI begins with the user.
Humans need to be incorporated in the very earliest stages of the design process. It's not an afterthought. It's not something you build a system and then, all right, it's ready, now let's test it with users. Because then when you find out all the flaws, and there's always going to be flaws, it's usually much more costly to go back and repair those problems than if you had incorporated some level of user assessment in the early phases of the development.
In human factors, we need to understand and address end user needs, limitations, and capabilities, both physical and psychological, and try to understand and address these end user needs, limitations, and capability in the design and operation of our technological system.
Who is going to use your software? You define that first. And through a series of user interviews, initial user interviews, you define what is it that they're capable of doing, what is it that they want from this product, of this software. We evaluate the design by a sample of our user population. So we go back to the user again.
For average user, we need to understand the issue of design for novice, for naive, and experience. So this is for naive, novice, and experience. This is very, very important consideration.
Systems are not designed by CS and EE people for CS and EE people. They're designed for broader user population.
So you'd be a big proponent of user-centric design.
Absolutely, absolutely.
The user is center to all this.
User is always involved. They're always sort of a feedback, loop back to the user. or directions that you mentioned may not be conflicting at all. The question is not whether the website should be simple versus complex. The question is how I can design a website that gives maximum capability to the user without making them confused and frustrated and angry and making errors, and that's the question.
Once we understand for what type of end user we are developing this product, then that knowledge should dictate which one of these two extremes we should get closer to.
Again, I go back to the principles that I espouse to it, which is you have to know what is it that the user wants to accomplish.
These two design extremes need to be based on whether the user is in need of a simple interface or a complex one, or somewhere in between. This decision needs to be based on their background with computers and interfaces.
If you are designing for a third world country type of a user that are coming from agricultural background, and we do a very good needs assessment and capability assessment, and that findings of that analysis should determine which one of these two models we should go and implement.
For example, if the user wants just to make certain choices, very simple choices, and say, well, I want to choose among these three, one, and then go to the next page, why should I give it a sophisticated, complex VR environment and make it more confused?
If you are designing for a very sophisticated end user with a changing need, that's another thing. Changing requirement, changing expectation, and that, of course, that's a totally different paradigm.
If the analyst decides that the user needs to be immersed in a realistic cyber virtual area space and interact with those objects in that complex way. If that's the case, of course, then VR is a good tool to do that.
I got a position in a brain injury rehabilitation program. These are folks like you or me, have a car accident, a stroke, a bullet wound, a fall off a ladder, whatever. I noticed a lot of my clients had Game Boys, a lot of the 18 to 24-year-old population, which is the highest number of people that have brain injuries, a lot of risk-taking and car accidents, drunk driving, motorcycle accidents. But they all had Game Boys. They were becoming Tetris warlords, basically. And it showed me that if you make a training task interesting, compelling, exciting, like a game, that you'll get motivation and you'll actually see improvements on the task. So I saw this, and it coincidentally had just gotten a Nintendo 64 with a Sim City. And I don't know if you ever played this game, but it's the ultimate executive function training task. And I found when I brought this in, that some of my clients I couldn't motivate for 15 minutes were spending hours building cities. After seeing that, and then hearing more and more about virtual reality, it just hit me that, hey, let's develop virtual environments, virtual reality environments, and develop better ways to assess a person's current level of functioning as well as train their ability levels.
Dr. Rizzo's lab works on developing various tools for users to operate their computer in a more intuitive manner.
I'm sure you've seen alternative devices like Spaceball devices, 3D mice, and so on, and comparing how someone can select an object on a flat screen and manipulate it into a place. Not just simple, just dragging something across the screen, but something that maybe has some illusion of depth that you have to manipulate it and place it in a certain way. We can build environments that have really interesting interaction features that can make physical therapy more interesting, so people can reach and grab objects in a virtual environment and we can adjust the stimuli that they have to reach for things. So if they've just had a stroke and they only can move their arm this way, they can play a game of handball with just that movement, and we can get their movement going more and more by compelling that kind of motivation that would be very difficult to inspire in a person just using everyday tasks.
Dr. Rizzo also works with immersing the user in realistic environments.
We can now interact with our hands, we can look around and scan an environment, be in the environment rather than outside in the screen.
Using a panoramic camera, a 360-degree view of an environment can be recorded. After this video has been captured, it can be wrapped and put into a head-mounted display. Users who wear the head-mounted display can turn their heads and see and hear the events that took place in the recorded environment. This technology can be used for entertainment, but it can also serve a more important task. Psychologists can treat people who have a phobia of heights by displaying a rising elevator in the head-mounted display. This gradually allows the users to face their fears, even though they never actually leave the ground.
We've seen environments for fear of heights really impact somebody who has a phobia for heights, so that they get in the environment, never mistake it for the real world, but the stimulus cues are there and their heart's beating and their sweaty palms are happening.
Another benefit that this technology has is diagnosing children who have attention deficit hyperactivity disorder.
You are in the virtual classroom. What you would see here is what you would see in the head-mounted display. The way the person looks around the environment is based on this tracking device. This is an inertial tracker. This is about $1,000. This is what goes on the headset. So as I turn, what you see on the screen changes and shifts, and I can tilt it this way, and you can, whatever you're seeing on the screen is what I would be seeing in my head-mounted display.
Children being diagnosed are asked to pay attention to the virtual teacher while distractions are going on around them.
Non-diagnosed children will focus on this and do quite well. ADHD kids are looking at every possible distraction, looking around the room, missing targets. And this little device not only updates the graphics, but it also records how much they're moving. So we're actually getting
So you can
metrics
see
of head
where they're
movement.
going.
Yeah,
So a child who had
ADHDs moving
looking
around
around.
more, and we can quantify that.
The motions of the children with and without ADHD can be tracked and compared. When a man walks into the virtual classroom, the child with ADHD will turn to look at him, while the other child is hardly distracted. The same is true when a car drives by the classroom. Eventually, the child with ADHD begins to lose focus altogether, while the other child remains mostly focused. Children with ADHD find these stimuli distracting.
Well, in the classroom, it wasn't the noise that with all the children outside of the classroom, but with the person opening up the door, closing it, opening it up and closing it, that was kind of annoying, and so was the car honking and stuff keep on going by.
With these different applications of this technology, we see that virtual reality is a very capable tool for humans interacting with computers.
What VR has done is given a really cool and interesting platform for driving human-computer interaction research, so that people try to think of creative and alternative ways for people to interact with digital content. I mean, ideally, you could say that a virtual reality application, it provides a new type of interface for interacting with computers and extremely complex data. This is sort of conceived of as the future of gaming, in the sense that we're not yoked to hitting the W and the S key and whatever to navigate around. We can actually use our body and get a sense of being in it. So in a sense, we're talking about, at its purest form, a more intuitive way to interact with computers and extremely complex data.
Human-computer interaction has come a long way since the early days of digital computing. If things continue in the direction that they've been going, we can expect interfaces that are more intuitive and easy to use. How we will relate to computers in the future is something that people have always tried to predict. Companies try to guess how business will be conducted in a global market, and how people will communicate with each other over long distances. It may even be possible to not just send pictures and sound across great distances, but a sense of touch as well. Science fiction has also tried to guess how we will interface with computers. Perhaps someday this technology will no longer be just a prediction, but rather an integral part of our society that functions efficiently and easily. We can only hope that as computers become better, so also their interfaces will become easier and more intuitive.